JANZZ.technology, the podcast.
Hi everyone, welcome to another episode of JANZZ.technology's podcast. With me today is Jennifer Jayne Jakob, our tech writer.
Hi.
JJ, you recently wrote about how important data is these days for any successful organization. So, why is that?
Well, the main idea is that big data is supposed to help organizations make better decisions based on actual evidence, i.e. backed by data, rather than just following gut feelings or assumptions.
But it is all about just having more and more data?
No. I mean, of course you need a lot of data if you want to draw any kind of meaningful conclusions from it. For instance, if you want to know why your customers prefer product X over product Y, you wouldn't just ask 3 random customers and then base your entire strategy decision on that. You'd want to ask as many as possible, right?
Right.
And you'd want to find out what factors influence their decision. Back in the days before the internet became commercial, this information was gathered in time-consuming market research studies, customer surveys, and the like. But at some point, when businesses moved online and mass data collection and storage became feasible, people realized that they could track not just what customers bought, but how they navigated through a site, how they're influenced by promotions, reviews, and page layouts, and all sorts of other behavior. So they started gathering data, more and more and more data, about more and more aspects of customer behavior. The thing is, businesses don't just grow simply because they're sitting on a mountain of data. You have to do something with that data. It needs to be analyzed. And you clearly can't analyze hundreds of terabytes of data by hand. You need analytic tools. You need algorithms, machine learning models, the works.
Sure, data is not magic. You need tools to do something with it. But surely, the more data you feed those tools, the better the outcome, right?
It's not quite that simple. New data itself doesn't necessarily equal new intelligence, no matter how good your tools are. You see, big data is messy. If you don't have the right strategy, your data can end up just being a great, big, expensive, useless jumble. Put bluntly, even the best tools can't turn a stinky mess into sweet-smelling roses.
Okay, got it. So if more isn't more, then what is?
Well, let's go back to the old school market research studies pre-internet. They were about collecting data too. But no one would have just collected all sorts of random data on their customers. Apart from being really inefficient, any market researcher will tell you that to get meaningful insights, you need a well-designed study. You want to ask the right people the right questions and somehow organize the results so that you can compare them and verify them, etc. And we're speaking about a time when data was analyzed more or less exclusively by human intelligent beings. These days, we want data to be understood by machines or algorithms as well. And contrary to what many people think, algorithms, even AI-based algorithms, are actually pretty dumb, at least to start with. They're much faster than humans, sure. But if you want them to be smart in any sense of the word, you need to feed them smart data.
What do you mean by that?
Think of an AI or machine learning model as a child. Under the right circumstances, children love learning. They soak up any information you offer and constantly try to make connections and find patterns to understand how all sorts of things work. And their understanding grows with the feedback they get. But if you just throw anything and everything at them, unfiltered random tidbits taken out of context, they'll get overwhelmed and confused pretty quickly. They can also develop biases and prejudice. So ideally, if we want kids to grow up to be smart, unprejudiced human beings, we need to give them information that's somehow curated, the right amount, on appropriate topics, put into context, with the right annotations. In other words, we want to pass on our knowledge. And the same is true for AI or machine learning models. They need curated smart data to become what we want them to be. Models that can find and use the most impactful data faster to learn more accurately how the world works and provide meaningful insights to us. That way, we and our businesses can really use these tools and all that data to move towards truly evidence-based action instead of just spending our days guessing.
Okay, so I get why we need this smart data, but I'm still not quite sure what it is.
Smart data is data that's based on standards and explicit semantics, i.e. on the actual meaning of concepts. It's both machine and human interpretable, linkable, contextualized, and reusable. It's neither redundant, unnecessary, nor duplicate. And its value is that it can be used directly to answer specific business needs or to accomplish predefined outcomes.
Good. So if we want our business to become data-driven, what do we need?
The first thing you need is a well-designed data strategy. Collecting data is not about filling a magic pot and expecting whatever comes out to grow your business. Think about what you want to do with the data first. What information is valuable to your business? What do you need to know about your decision-making processes? In other words, what is smart data for you? This will determine what data you collect and how, your data architecture, the team you need to get it done.
So use the outcome to decide the income.
Exactly. Smart data needs to be right at the start of the design process. This really can't be stressed enough. If you just start collecting data without a good strategy, you're very likely going to end up paying a lot of money for a highly skilled data team to spend around 80% of their time cleaning and renaming JSON files. And just think about the storage for possibly terabytes of unproductive and redundant data. On top of being really expensive, it's not exactly environmentally friendly.
Okay, I'm sold. So how do we get smart data, or how do we convert big data into smart data?
As I mentioned before, you need to have a clear understanding of what your individual smart data looks like from the get-go, and go for complete control of your data structure. Then you need to find the right data sources and aim to really collect only the data that's truly relevant to your use case. Most raw data from these data sources will need to be cleaned, verified, and standardized, so you should make sure to design your data ingestion with a clear vision of your input data in mind. You'll want to automate this as much and as well as possible. You'll want to add filters and annotations to the data too. Crucial step, though, is contextualizing the data.
Meaning?
Suppose you have a car. One thing you'll want to measure is the motor temperature, because this will give you information on how that motor is doing. You definitely don't want your engine to overheat. But rising temperature alone does not necessarily imply impending doom and engine failure. Higher speeds can cause higher temps too. So contextualizing temp data with speed data can offer more insight. And if your engine really does overheat, you'll probably want to know why so that you can fix it. So you could add data from sensors in the cooling system, maintenance history, etc. All these additional layers of data will give you a multidimensional context along with useful insights to help diagnose issues and correct unfavorable behavior. And the more dimensions you have, the more relationships you'll see and the more context you can create, giving richer, more meaningful insights.
Sounds great in theory, but how does it work in the real world? How are you supposed to track down all the relationships for each data point?
Definitely not by hand.
I hope not.
Basically, what we're talking about here is saving data as knowledge as opposed to simply saving information. So your contextualization tool has to somehow or other be able to draw on knowledge. In our motor example, this tool needs to know what all the different factors like temperature, speed, cooling elements are and how they interact with each other. And because the tool is just a mindless tool that knows only what we tell it, we need to feed it expert knowledge in the form of bits and bytes. So all those different data tags need to be mapped into a kind of model of interconnected dots that the tool can read and act on. Or in more fancy terms, the application needs to have access to a knowledge representation in the form of a domain-specific knowledge graph, or ontology as we call it.
Ontologies. We spoke a lot about them in the last episodes of this podcast. Tell me more. How does this combination of humans and machines work?
Well, as I said, they're a way of representing a certain area of knowledge in a way that machines can use it. The more intelligent, and I really mean that in inverted commas, your application needs to be, the more important it is to have a good representation of the knowledge it needs. In these kinds of applications, knowledge is typically represented as a directed graph. This is a collection of nodes, or dots, representing the individual concepts in your domain of interest, for instance, temp, speed, cooling elements and the like in the motor example, and edges, or lines, connecting the nodes. The edges represent the relations between the concepts, and the graph, so the collection of nodes and edges, is directed. This means that the edges have a direction. Think of an arrow, because the relation typically doesn't go both ways. For instance, increasing speed will lead to rising temperature, but rising temperature doesn't necessarily mean that the speed has increased or will increase. The application can then walk along this graph, learning the concepts and how they relate to each other.
And where do humans come in?
Someone has to build this knowledge representation. There are a lot of knowledge graphs or ontologies out there that are based solely on machine learning and other automation techniques. But generally speaking, the outcome with these is typically, well, what you'd expect from the blind leading the blind. The really good ones are primarily hand-curated by a team of subject matter experts, humans, with some support from supervised machine learning systems, say to help integrate new or changed real-world data, like our job and skills ontology here at JANZZ.technology.
So, maybe following with the JANZZ.technology example, how do the domain experts help? Why are human-curated ontologies better than machine-generated ones?
Unlike machines, human subject matter experts are aware that there are such things as subtleties and grey areas, ambiguities, implicit skills, typos, etc. For a job and skills ontology, these experts can go and research an obscure new term like data ninja to work out what kind of job this is, whether it corresponds or relates to one that's already in the ontology, what skills you need for that job, and so on. Of course, machine learning algorithms can be trained to work out some of this too, but so far, the quality is simply not comparable.
Why do you think that is?
One of the key reasons is that machine learning is based on statistics. So it can only ever be about recognizing patterns and guessing the statistically most probable meaning. This can go comically wrong. Take, for instance, the word pen. The most common use of this word is as a writing utensil. So what do you think a machine learning system would do with the sentence, "The sheep is in the pen"?
Probably something funny.
I mean, even a 3-year-old child would get the right meaning immediately. That's because we humans have common sense and common knowledge and can make use of this to actually understand the meaning. And remember, ontologies are about representing knowledge. You simply can't have knowledge without meaning.
True. But ontologies are not a new thing, right?
Right. Ontologies have been around in AI research for the last 40 years. And they've had their ups and downs like many other approaches. But there are a lot of powerful ontologies out there for specific domains. For instance, the financial industry business ontology, FIBO, has been around for quite some time. We've been developing and improving our job and skills ontology here at JANZZ.technology for the past decade now. And there are numerous other ontologies for healthcare, geography, systems engineering, you name it. I'd say one of the main drivers of the current comeback of ontologies was probably the launch of Google's Knowledge Graph in 2012, which is actually not quite the same thing. Still, these days, all the big players are using ontologies in all sorts of domains to organize and contextualize their information to boost performance. Social media networks, streaming providers, electronics manufacturers, supply chain logistic companies. They're even used in forensic accounting. These organizations have caught on to the fact that big data alone is not enough, and that for successful AI-based technologies, smart data is simply indispensable. And this is where ontologies come in. By representing contextualized information, they're basically smart data management systems that can drive performance by feeding the machines with real knowledge in readable form to produce meaningful and actionable insights.
So, in a nutshell, start using applications based on knowledge graph if you want to unlock the full potential of your data.
Exactly.
Thank you, JJ, for joining me today.
My pleasure, Laura.
Thank you for listening, and goodbye.
If you want to learn more about HR technologies, subscribe to this podcast or visit our website, JANZZ.technology. You will find new podcasts every month. Thank you for listening.